So as I said, apologies for the delay. We had a bit of a technical issue, so we are ready to start now. So this session is about talking about developing Lambda functions in Python. So I'll provide a brief introduction of what AWS Lambda is, and then talk about how to develop Python functions at different levels of complexity, starting with relatively simple implementations to some more complex examples. And feel free to ask any questions during the session. And at the end of the session, we'll have some extra time to take some further questions. So before we kick off, a little bit about myself. So my background is in software engineering and business. I've worked in the technology sector over the last 18 plus years in different development management roles, working for different telco, oil and gas, and retail customers, and eventually working with a number of different life sciences customers. So I currently work as a specialist machine learning and high performance computing solutions architect with AWS, primarily working with healthcare and life sciences customers, focusing on drug development, research, and clinical trials. So I would like to give a brief overview of what AWS Lambda itself is as a service, and then talk about implementing Lambda functions using Python. So I'm assuming people have some familiarity with different AWS services, and Lambda being one of the key, what we call serverless services. So it's essentially a compute service that lets you run code without provisioning or managing servers. It runs your code on a high availability compute infrastructure and performs all the administration of the compute resources, including server and operating system maintenance, capacity provisioning, automatic scaling, code monitoring, and logging. Using Lambda, you can run code for virtually any type of application or backend service. So all you need to do is supply your code in one of the languages that Lambda supports. So the languages that are currently supported include Python, JavaScript, Java, Golang, and C#. Plus, you can bring your own languages if you can package them using the runtime environment that it needs to run. Typically, you invoke your Lambda functions using the Lambda API, or Lambda can run your functions in response to events from other AWS services. So for instance, you can use Lambda to build data processing triggers for AWS services such as Amazon Simple Storage Service, also known as Amazon S3, or Amazon DynamoDB. So basically, what that means is you push in or submit new data into one of these storage repositories, and you configure a trigger that responds to any change or any new data being added to these repositories. You can also process streaming data stored in services like Amazon Kinesis, for example, to build some real-time APIs, etc. Lambda is considered an ideal compute service for many application scenarios, as long as you can run your application code using the Lambda standard runtime environment and within the resources that Lambda provides. And we'll talk about that a little bit when I'll show you some examples. So at a high level, from a user or customer perspective, Lambda basically provides different triggering mechanisms. So event source mapping being one of them, or triggers, as I mentioned before. It can be positioned as an API using services like the API gateway. In addition to that, you have to set up permissions and roles for the Lambda function that you're creating. Essentially, what that does for Lambda is it gives it permission to access certain resources within AWS. For example, accessing databases or S3 buckets, which is the simple storage solution I mentioned before, etc. You can build your code either within the Lambda console or using the SDKs provided. So you can package them as zip files or container images, or simply you can use the built-in IDE to develop the code. Additionally, you can use certain configuration features to set things like environment variables, for example, or level of concurrency to be able to scale your functions and so on. And Lambda takes care of the execution environment under the hood, And then there are certain features around versioning your functions. So versioning essentially means that as you continue to develop your functions, if you need to make changes, you can keep track of those changes by versioning your functions, which essentially you can do using something like Git as well. But this is also from a deployment perspective. If you have released a specific version of code and you want to make sure that you have some sort of auditability in place. And essentially, it also allows you to do things like what is referred to as blue-green deployment. So for example, in this picture, you can see we have this concept of alias in Lambda, and you can have a production version of your code deployed. So essentially that alias is pointing to two different versions of the Lambda function, and it's diverting traffic. So in the first example where alias is prod, it's diverting traffic 80% to version 1 and 20% to version 2. And I'll go into a bit more detail when I show some examples just to explain what this means. So I also mentioned packaging. So your Lambda functions code consists of scripts or compiled programs and their dependencies. You use a deployment package to deploy your function code to Lambda. And Lambda supports two types of deployment packages: container images and zip file archives. To create the deployment package for a zip file archive, you can use a built-in zip file archive utility or any other zip file such as 7-zip from your command line tool. So you can deploy your Lambda function also as a container image. So AWS provides a number of resources to help you build a container image for your Python functions. So for example, there is an AWS base image for Lambda. These base images are preloaded with the language runtime and other components that are required to run the image on Lambda. And AWS provides a Docker file for each of the base images to help with building your container images. And there are some open source runtime clients. So if you're using a community or private enterprise base image, you essentially just add a runtime interface client to the base image to make it compatible with Lambda. So I would like to show a few examples in terms of how to develop Python code in Lambda. So I'll start with a very simple example. So essentially, when you're starting to develop functions in Lambda, you go to the AWS console, you select the service, and you just select create function. And there are some blueprints available, which gives you essentially some sort of a template for a number of different use cases. So for example, processing stream using DynamoDB, microservice, HTTP endpoint, etc. If you want to use this as a reference to, if you find a template that is of use to you and you want to use it as a reference, you can start with that, or essentially you can just start authoring your code from scratch. And you can also select any container images if you have containers maintained in what we call an ECR repository. So ECR is the elastic container repository used by provided by AWS to maintain Docker containers within your AWS account. So in this example, if I click on browse image, if I had any repositories here, so you can see I have a couple of repositories. If I select one of them, you will see the different versions of the images I'm maintaining in that particular repository. So I'm going to start with the first option, authoring from scratch. So if I just say example function here, and I can select a number of different runtime environments that I mentioned before. So we have a number of latest supported versions of each, and then there are some previous versions which are supported. So for Lambda, it's sorry, for Python, it's 3.7, 3.6, and 2.7. I'll just select one of those just for. Okay, so after we click create function, it will take you to the screen where it will present you an IDE. And here you can start writing your code. So it gives you this file called lambda function.py, and it has a very basic definition or method template in here, and it typically names it Lambda handler. So Lambda handler is basically the entry point into your Lambda function for any external resource that is making a call to Lambda. and it is specified here in the properties of the function, so runtime settings. And if you want, you can change this. If you have a number of different files in your IDE and you want to point to a different file and make that the entry point, you have the ability to do that. So I'll leave this at that for now, and I just wanted to show you that this is the starting point of starting to develop Python functions in Lambda. I have an example which I've already written, a very simple example of interacting with DynamoDB. So in this example, I'm creating a function to expose a REST API for a rider app, which essentially will allow riders to register with the system. And this particular function is going to submit their details to a backend database, which in this case is DynamoDB. So before I'm able to run this or start developing this function, there are certain prerequisites I need to take care of, which I'm going to talk about now. So the first thing is I need to have almost always you'll have to interact with a service within AWS when you're working with Lambda functions. So Lambda is essentially responding to calls from an API or some sort of an event being triggered, etc., and then it's taking an action, which in most cases would be writing to a database, starting another job in a different service, and so on. In this particular example, we'll be writing to a database, so we need to make sure we have the database set up. In this example, this is a DynamoDB database. So if I go to DynamoDB, so DynamoDB is also a serverless version of database, so NoSQL database, and you don't really need to create separate databases. You just create tables within the service itself. So in this example, I've already created a table named rides, where I'm storing all the information pertaining to the riders who are registering their details. So I've created some sample data here when I was testing this before. So after creating the database, the next step is I have to make sure my function has all the permissions to be able to interact with the database. So what I need to do next is in the service called IAM, which is the Identity and Access Management Service, I will make sure I have roles. I have a role set up that is able to, that gives Lambda the permission to interact with the DynamoDB. So I've already created a role by the name of rides Lambda execution role. This will essentially serve as an execution role for Lambda. So what that means is it will Lambda will assume this role on the behalf of any application that's going to be running that function to perform certain activities. So in this case, I have given this function, in addition to the basic execution role permissions, I've given it permissions to get items or get records from the DynamoDB table, and I've given it permissions to write to the DynamoDB table. And I've restricted the permissions of this particular role to the specific table I want to be able to write to. I haven't given it broader permissions, and this is very important from a principle of least privilege point of view, because you don't want to give excessive access to services that are you're deploying in your application. So if I go back to the Lambda function I was referring to earlier, so here I have imported certain dependencies I'll be working with. So the most important one is Boto3. So Boto3 is the Python SDK for AWS. So you can, using Boto3, you can interact with a number of different services, and you can use this to write Lambda functions, etc. So I'm using Boto3 here to basically interact with DynamoDB. So Boto3 has a concept of resource. So when you make a call to resource, you can specify which service you want to interact with, and it essentially creates a client for that service for you. So after creating that client, I'm specifying which table I want to work with, and then within the function, I am then creating or I'm constructing my record set that I want to submit to the table, and then I'm calling this put item function, which is part of the Boto3 SDK for DynamoDB. So what this essentially does is it submits a new record into the database. So in order to be able to test this, that this is working properly, I have the option of configuring test events. So as I mentioned before, Lambda works primarily with events. So whether you are setting up a trigger to invoke Lambda function from another service, or whether you're using REST APIs or using any other mechanism to start or trigger the Lambda function, it essentially receives the call in the form of events. So what you can do is you can specify the signature of your event here, saying that this is what the data I'll receive as part of the event that will be sent out to Lambda, and I need to act upon the different data parameters that it will submit. So in this case, I've constructed this sample event. So I have things like driver name, vehicle information, registration, capacity, and so on, which I'll be using to submit it to the backend database. If you want to create test events, there are a number of templates available to create test events for a number of different services, like for Alexa, for DynamoDB, for S3. So if I look for S3 test events, there are S3 put, S3 delete, etc. So you can use them as the starter templates to create your own test events. So what I'll do now is I'll just run a quick test against using the test event I've already configured, and it will show you in the ID here the results of the execution. So it has submitted the record to the database in the backend, and it got 200 response back, which means it was successful in submitting the record, and the record has been added to the database. So this is a very relatively simple example of writing a Python function in Lambda. A bit more, let's say, mature example of doing the same thing in Lambda would be trying to make this a little bit more modular or segmented. So what I mean by that is in your Lambda function, your Lambda handler is, or whatever your entry point function's name is, this should be essentially calling other functions to do a number of different activities if your function is doing something relatively complicated. So this example is not that complicated, but just to demonstrate that point, what I've done here is I have written two additional functions which are performing two of the tasks that the previous example was performing, but they have been separated out in different functions. So one of them is saving the data into the database. So it's calling the same put item function here, but additionally, and then getting the data I've just submitted to the database using the table.get item function here. And in the main entry point in the Lambda handler function, what I'm doing is I'm calling the save rider function here, and then I'm calling the get rider function, and the response of that is returned as a result of the function. I've also made a few modifications here. So I was submitting a lot of static values before. Now I am sourcing some of these values from the event information. So the construct event that I just explained. So basically, when the function gets triggered, some of the event data will be read by the function and used to submit that data to the database. So if I can, yeah, so sorry. Here, for example, I'm from the event object, I'm reading the driver name value, and I'm using this later on to submit that value to the database. I'm doing the same with vehicle registration and capacity. So I'm basically reading all of these values from the event object. Okay, so if I run a test against this function, the result here is going to be slightly different, because in addition to getting the success response from Boto3, I'm also getting the results of the get item call I'm making to DynamoDB. So this is the record that I've just submitted to the database. So it's just kind of confirming that this record has been created in the database. So another a bit more advanced example I've built here is basically around using environment variables. So I mentioned environment variables briefly before. So environment variables help you make your code production grade essentially. So for example, if you're in development and you have one AWS account you're working in and your production code runs in a separate AWS account, or even within the same account, there are some um, gating procedures in place and you're not the one who's deploying it into production, you may want to make sure you're not hard coding certain values for which the production environment's values are different. So in this example, table name and the rider API URL. So you would want to retrieve that from the environment variables, and because when you're deploying the same function to in a different setting, you can just simply modify the environment variable rather than having to change your code itself. So the way to go about doing that is you go into configuration, and you have a number of different options in configuration here. Like you can have set up some triggers, etc. You can set up your concurrency values to make your function a bit more scalable and so on. We are focusing on environment variables here. So what I've done is in this particular example, I've set up these two environment variables, and these are the values I've given them. So when I execute this function, these values are passed on to this function, and I'm reading those values using this os.environ construct. So basically, I'm importing this as a dependency, and then I'm calling this to assign these values before I'm using them to basically submit the data to that specific table in the database. Okay, so this is one way of developing applications in Python in Lambda. Another option I mentioned was building containers and submitting those containers to Lambda to be executed. So I have another working example of a function that I've written, and this function was written to build what we call a machine learning or an inference endpoint. So basically, you have a machine learning model, and you want to make that machine learning model available as an API to different users so they can make a call to that API and get some sort of predictions. That's kind of the simplest possible use case for an inference endpoint. And in this example, I want to set up that inference endpoint as a Lambda function. And because it has the endpoint will require a number of different dependencies, I don't want to, well, I have two options. Either I create that a zip archive for that, or create a container. So in this example, I decided to use the containerization option, and what I've done is I've written the inference code in this file app.py, and I won't go into too much detail here. This is more to do with machine learning than writing Lambda functions in Python functions in Lambda. But you can see there are certain libraries which are using like torch vision and torch.nn, etc., that are needed for this function to work. So we have to import these dependencies. So in a typical Python environment, you will have a requirements.txt file. So that's what I have here. I'm going to compile this as a Docker container. So I've defined all the dependencies I need for this inference endpoint to work. So I need Flask, Torch Vision, Torch, etc. And then I've created a Docker file. And in this Docker file, I'm using a base image, Lambda image provided by AWS. So this is something that I mentioned earlier. And additionally, I'm copying the app.py and requirements.txt file. And then I'm starting, and then I'm basically installing the dependencies, and then I'm calling the Lambda handler just to kickstart this process. So what I'm doing next is I'm going to be building this function using SAM. So SAM is basically a toolkit for serverless application development. It's a CLI client. It can be used to deploy Lambda functions. It can be used to basically build your containers, Docker containers, and push them into AWS. So in this example, basically I'm calling the SAM build and SAM deploy methods. And you can find more information about how to go about using SAM, and I can provide some links if people want to know more about this. But essentially, I'm using this toolkit to build my container. So it will start building the container. You can see it has successfully built it, and now it's asking for certain parameters for me to configure this in the AWS environment. Here it's asking me for the image repository for this container to be pushed into. So basically, I need to save this into um, ECR repository or Elastic Container Repository, where I can keep this and where Lambda can use it for basically pulling the container and running the function. So what I'll do is I'll copy the URI, because I've already set this up, the repository in ECR, and I'll specify this as the repository I want to save this image to, and then it's asking me for a few other confirmations. And you can see that it has pushed this image into ECR, and it's performing some other operations there. But the end result is going to be that you'll have a new version of this image here, and then it's going to set up the Lambda function on your behalf, and it will be similar to the name. So this is basically the deployment that I did previously for the same function. So it has set up not only the function, but it has also set up an API gateway for you here to expose this as an API for external users. And you can see that there's no code preview available because this has been built as a container. And if I wanted to check out how this has been set up in the API gateway, you can just simply click here. And you can see that it has given it this name, Lambda SQLite inference. And if you go into routes, there's a get method available for users to query this API. Okay, are there any questions up to this point? Okay, so I also wanted to talk a little bit about versioning and how that works in Lambda and why is that important. So versioning basically, as I said, allows you to create some sort of auditability around how you have rolled out different features as part of your functions, whether it's in development, production, whatever. So I have an example here where I'm creating Lambda. I'm using Lambda to create what we call SageMaker domains. So this is SageMaker is a machine learning service in AWS, and we have a concept called domain that allows you to create notebook environments or development environments for data scientists to work with. So I'm programmatically setting up this domain as part of this function, and I have different versions of this function. So there's a version 1 and there's a version 2. Version 1 was created 8 months ago, and earlier today I created the second version. So I could potentially decide to use the latest version in production, or I could decide that I've recently rolled out this version and I'm not so sure if there are any bugs that I haven't detected as part of my own integration test. So what I could potentially do is I can create an alias. In this example, I've created a production alias, and what I've set to the production alias is direct 20% of the incoming traffic to version 1 and the remaining 80% to version 2. I could swap this over as well. So if I go in here and I say I want to have 50-50 split between these two, I can just change this number here. and it will split the traffic between these two versions half and half. So this is essentially what versioning and aliases are used for. Okay, so I also wanted to talk a little bit about some other considerations when developing functions in Lambda. So before I dive into this, I just want to talk a little bit about architecture. So essentially, in what scenarios would you want to use Lambda functions? Well, as I mentioned before, you can use them for almost anything in terms of a backend service or an API, etc. And typically, if you're building an application that requires performing a number of different functions, like this is an example of a very simple e-commerce application where you're creating orders, you're submitting packaging instructions to the warehouse, you're starting, you're managing deliveries and so on. All of these functions need to be automated, and the system that you'll build on, if you want to go completely serverless in AWS, will essentially be Lambda integrated with a number of different services. So a sample or an example architecture of this would be something that looks like this. This might look a bit complicated, but I just wanted to highlight how useful and essential Lambda is for some of the production grade applications that our customers actually use. So for instance, in this example, we have the product services like listing the products, catalogs, etc., managed by Lambda. It's interacting with DynamoDB here. It's exposing these APIs through API Gateway. We have order service built using Lambda. So again, they're exposed as APIs using API Gateway, and everything is stored in DynamoDB. And you see a similar pattern across the board for delivery service, warehouse, payments, etc. So in terms of performance and optimization, there are certain things you can do around scaling your Lambda functions. The first time you invoke your function, AWS Lambda creates an instance of the function and runs its handler method to process the event. When the function returns a response, it stays active and waits to process additional events. So if you invoke the function again while the first event is being processed, Lambda initializes another instance and the function processes the two events concurrently. So as more and more events come in, Lambda routes them to the available instances and creates new instances as and when needed. And when the number of requests decreases, Lambda stops the unused instances to free up scaling capacity for your function. So your function's concurrency is basically the number of instances that serve requests at a given time. For an initial burst of traffic, your function's cumulative concurrency in the region can reach an initial level of between 500 to 3000, depending on which region you're in. So this is something to keep in mind when you're using Lambda for essentially applications you want to scale. Then in terms of best practices, there are a couple of other things you could do to ensure that your functions are achieving your desired level of performance. They have the traceability, security considerations in play, etc. So from an observability point of view, you may want to set up tracing with AWS X-Ray for front-end observability. You may want to do structured logging for search and aggregation. So you could use CloudWatch to basically capture and use the logs. You can create logging repositories using search services like Elasticsearch, for example, and you can structure your logs based on what your downstream needs are in terms of analyzing those logs for operational purposes and so on. So a very simple example of that is, so in the some of the examples I showed to you before, I am creating some log events and I'm kind of giving them a specific structure. It's not something very sophisticated here, but you could give any given structure you like to make sure that you're capturing all the information that you need and it's structured in a way that is useful for your downstream applications. And then you can also build custom matrix with CloudWatch logs EMF. And there's another a tool called a Lambda power tools that allow you to basically use some of these things. Like you can see in this example, using Lambda power tools to capture matrix. It has its own built-in logger, tracer, etc. And then in terms of error handling, depending on what pattern you're using, whether it's synchronous, asynchronous, event source mapping, etc., you need to make sure that you're handling the errors. So basically in synchronous, you'll have some sort of an error handler in place. In case of asynchronous, you'll configure destination on the function to alert and store failures, and you set up that letter queue in case of event source mapping. So in our example, I was simply trying to capture some of the errors. So for example, this is a key piece of information needed for this particular function. And if this is not present, it will raise log an error and basically raise an exception. And then in terms of function optimizations, so when you create your Lambda functions, you specify configuration information such as the amount of memory available and the maximum execution time allowed for your function. Lambda uses this information to set up the execution environment. So this can be done in Lambda in the configuration bits here. So the general configuration, this is here, you can specify how much memory you want to allocate to your function. So you can go up to 1 gig, and then you can set up the timeout threshold here up to 15 minutes. So when the functions runtime and each external extensions set up, these are the processes that run within the execution environment. Permissions, resources, credentials, and environment variables are shared between the function and the extensions which are part of your runtime environment. So if you want to optimize your function, you should take advantage of the execution environment reuse to improve the performance of your function. So essentially what that means is initialize SDK clients and database connections outside of the function handler, and cache static assets locally in the temp directory, for example. Subsequently, invocations processed by the same instance of your function can reuse these resources, which then saves cost by reducing function runtime. Additionally, to avoid potential data leaks across invocations, don't use the execution environment to store user data, events, or other information with security implications. Because if your function relies on a mutable state that can't be stored in memory within the handler, consider creating a separate function or separate versions of a function for each user. And then there are some other considerations like use environment variables to pass operational parameters and minimize the size of your deployment package to its runtime necessities and so on. And then there are a number of other useful resources available. So security guide around AWS Lambda, this well-architected paper on serverless lens. So basically it gives you some guidelines on how to build serverless applications, and that includes Lambda, but other serverless applications like DynamoDB and Aurora, etc. There's more information about power tools in GitHub, and the whole SDK is available here. And a number of there's this library provided by one of the developers, AWS Lambda Power Tuning. Plus, there's a lot of documentation about AWS Lambda and how to optimize performance in Lambda, etc., on the AWS website as well. So that was pretty much what I wanted to cover today. Is there any questions anyone would like to ask? Okay, so if there are no questions, I would like to thank everyone for joining, and apologies for a lot of noise in the background. I have a handful of kids at home, and it's not easy working from home with you know. So apologies for that, and I hope everyone learned something today and they enjoyed the session. Thanks a lot, everyone. Bye.